Hello everyone, this is your teacher Ryan. In this video, we're going to solve 30 problems in basic calculus at the senior high school level. This can be used as a review for your final examination or a refresher tutorial if you would like to remember what you have learned in your basic calculus class in the past. These problems cover three topics: the limits of a function, differentiation, and anti-differentiation or integration. So let us start. Question number 1. Find the limit of x squared minus 4 divided by x minus 2 as x approaches 2. Take note that if you substitute 2 right away, the denominator would be 0. However, if you factor the numerator, x squared minus 4, into x plus 2 minus x times x minus 2, x minus 2 in the numerator and denominator will be cancelled. So you will be left with x plus 2. Substitute x equal to 2. The answer is 4. So the limit of x squared minus 4 divided by x minus 2 as x approaches 2 is equal to 4. Next question. Find the limit of the square root of x plus 4 minus 2 over x as x approaches 0. Again, if you substitute x equals 0 immediately, the denominator would be 0. So our approach is to rationalize the function first. So we multiply both the numerator and the denominator by square root of x plus 4 plus 2. So essentially, we are multiplying the function by 1 because the numerator is equal to the denominator. So this becomes x plus 4 minus 4 over x times the quantity square root of x plus 4 plus 2 as x approaches 0. So here, 4 will be cancelled because 4 minus 4 is equal to 0. And as you notice, x will also be cancelled. So what's left is 1 over square root of x plus 4 plus 2. So you get the limit of that as x approaches 0. You simply have to substitute. So it will yield 1 over 2 plus 2 or 1/4. So that is the limit of the function. Next question, number 3. Consider the following function: f of x equal to negative 2x squared plus 3x for x lesser than 1, and x or f of x equal to x plus 5 for x greater than or equal to 1. Find the limit of f of x as x approaches 1 from the left. So this is a two-sided limit, and because we consider 1 from the left, that is the significance of the negative sign at the exponent of 1 or at the superscript of 1, we will use the value of the function for x lesser than 1. So we find the limit of negative 2x squared plus 3x as x approaches 1. So we simply have to substitute negative 2 times 1 squared plus 3. The value is equal to 1. Therefore, the limit of f of x as x approaches 1 from the left is equal to 1. Next question, number 4. What is the limit of 6x squared minus 5x plus 2 divided by 9x squared plus x minus 1 as x approaches infinity? So we can solve this in two ways. By inspection, we take note that the highest exponent of x for both the numerator and the denominator are is equal to 2. So they have the same highest exponent of x. So you simply have to consider the numerical value of x squared, 6 over 9, that is equal to uh, 2 over 3. So you know immediately that the answer is 2 over 3. But of course, the other way is to divide each term by the highest exponent of x, or by x raised to the highest exponent, which is x squared. So that is what we're doing now. So 6x squared divided by x squared and so on. Now, take note that so x squared divided by x squared is equal to 1. Now, for those terms that have an exponent of x, if you get the limit of that as x approaches infinity, it approaches 0. So you're just left with 6 over 9, which is equal to 2/3. That's the final answer. Next problem number 5. Find the limit of sine 2 pi times x, 2 pi x divided by 5x as x approaches 0. Now, if we let u be equal to 2 pi x, we can write x as u over 2 pi simply by dividing both sides of that equation by 2 pi. Next, we substitute this in the original equation. So the limit of sine 2 pi x over 5x as x approaches 0 can be written as the limit of sine u over 5 times x, but x is equal to u over 2 pi, as u approaches 0. So we change the variables. So you can write this as the limit of sine u over u times 2 pi over 5 as u approaches 0. Now we take note that the limit of sine u over u as u approaches 0 is equal to 1. This is an important identity. So because of that, the limit of sine u over u as u approaches 0 is equal to 1. That is the first part of the equation. So you're left with 1 times 2 pi over 5. Therefore, the limit of 2 pi x over 5x as x approaches 0 is equal to 2 pi over 5. That is the final answer. Next question, number 6. Find the limit of tangent x as x approaches pi over 2. So we take note that tangent x is equal to sine x over cosine x. You've learned that from trigonometry. So we can write the limit of tangent x as x approaches pi over 2 as the limit of sine x over as x approaches pi over 2 divided by the limit of cosine x as x approaches pi over 2. So that is equal to 1 over 0 or infinity, because yeah, so the answer is infinity. Okay, so next number. Find the limit of e raised to 3x minus 1 divided by x as x approaches 0. If we let u be equal to 3x, x is equal to u over 3. So we can write the limit of e raised to 3x minus 1 as x over x as x approaches 0 as the limit of e raised to u minus 1 divided by u over 3 as u approaches 0. And we can write this further into 3 times the limit of this term. Now we take note of the identity, the limit of e raised to u minus 1 over u as u approaches 0 is equal to 1. So you're left with 3. Therefore, the limit of the function is equal to 3. Next question. So this is the 8th problem. Find the limit of e raised to 2x minus e raised to negative 2x divided by x as x approaches 0. So this is a more complicated version of the previous problem. But what we would like to do is to express this equation in the form limit of e raised to u minus 1 divided by u as u approaches 0, because we know that that is equal to 1. So we write the limit of e raised to 2x minus e raised to negative 2x divided by x as x approaches 0 as the limit of e raised to negative 2x. Now the first term here will become e raised to 4x, right? Because if you add the exponent, the result will be 2x. So we can write this further as the limit of e raised to negative 2x times e raised to 4x minus 1 divided by x. So if you get the limit of the first term, that is equal to 1. So we're left with the second term, the limit of e raised to 4x minus 1 divided by x as x approaches 0. We let u be equal to the exponent of e, 4x. So x is equal to u over 4. So we substitute this. So we have the limit of e raised to u minus 1 divided by u over 4 as u approaches 0. Or you can write this as 4, limit of e to the u minus 1 over u as u approaches 0. And you know that term is equal to 1. Therefore, you're left with 4. So the limit of e raised to 2x minus e raised to negative 2x over x as x approaches 0 is equal to 4. Next problem, problem 9. Which values of x does the following function f of x equal to x squared minus 2x minus 15 divided by x squared plus 4x plus 3 have a removable discontinuity? Take note that removable discontinuity is also known as whole discontinuity. So we analyze the equation. If we factor the equation, so the numerator becomes x minus 5 times x plus 3. The denominator is x plus 1 times x plus 3. So the simplified version of this would be x minus 5 divided by x plus 1, but we will not do it that. So by inspection, if the value of x is equal to negative 3, you see that the numerator and the denominator would be both equal to 0. We have a value that is indeterminate. So that is a characteristic of a removal discontinuity. On the other hand, if x is equal to negative 1, the value of the denominator would be 0. So you have infinity. So that is a case of an infinite discontinuity. So we take note that we are looking for the values of x that would make the denominator be equal to 0. So to answer this question, the value of x must be negative 3. Next item, number 10. What function will redefine f of x equal to x squared plus 2x minus 8 divided by x squared plus 6x plus 8 to make it continuous. So to solve this problem, we analyze the function first so that we can identify the types of discontinuities that are present in this function. So we can write the original function as follows. So we factored the numerator and denominator. So we take note that we are interested for the values of x, wherein the denominator becomes 0, right? So for x equal to -4, you know that the numerator and the denominator both become 0. So it is an indeterminate value, characteristic of a removal discontinuity. For x equal to -2, the value of the function would be infinity. That is numerator divided by 0. So what you have is an infinite discontinuity. So to make the function continuous, we are only concerned with the removable, I'm sorry, this must be removable discontinuity or whole. So the original equation can be written in a more simplified form. So this is the form wherein we factored the numerator, we factored out the numerator and denominator. We cancel x plus 4, so you have x minus 2 divided by x plus 2. So our goal is to find a function wherein it is continuous at x equal to -4. So what we do is we get the limit of the function of the simplified version of the function as x approaches -4, and the value is equal to 3. So to make the function continuous, we define the equation f of -4 be equal to 3. Next problem, given the equation f of x equal to x plus 2 for values of x lesser than 0 and x minus 2 for x greater than or equal to 0. Identify the points or the point where the function f of x has a finite jump discontinuity. So one approach is to analyze the function graphically. Note that it is easy to graph this function. So you have the x and y axis. For x lesser than 0, that does not include x equal to 0. So what you have is a plot that slopes downward to the left, and the other one, for the other plot, it slopes upward to the right. So you see that there's a jump discontinuity at x equals 0. Next, number 12. Given the following function, f of x equal to 2x plus 2 divided by x squared plus x minus 3 over x plus 4. Identify the value or values of x where infinite discontinuity occurs. So you take note that this function has two parts. We must consider both of them. What we can do is to simplify the function first. We can take 2 out of, we can factor 2 out, right, in the numerator, and also x in the denominator in the first term. the second term would be the same. Then let's analyze the equation. For x equal to 0, the denominator of the first term will be equal to 0, while the numerator is not equal to 0. So f of x is equal to infinity. So you have an infinite discontinuity at that point. Next, at x equal to -1, the numerator will be equal to 0 because of x plus 1. The denominator will also be equal to 0. So you have 0 over 0, indeterminate. So what you have is a removable discontinuity. And finally, if you analyze the second term of the function, for x equal to -4, the denominator will be equal to 0, but the numerator is not equal to 0. So f of x will be a certain value divided by 0 or infinity. So what you have is an infinite discontinuity. Therefore, the answer would be x equals 0 and x equals -4. Two values for x for infinite discontinuity. Next, number 13. Given the quadratic equation, remember that in a quadratic equation, the highest exponent of x is 2. So f of x equal to x squared plus 2x minus 3. Apply the indeterminate value theorem or IVT. Over the interval -5, 0 to find c such that f of c is equal to 0. So essentially, you just want to find the value of x wherein the value of y is equal to 0 in the given interval, which is -5, 0. So the procedure in applying the IVT is first to check the continuity over the interval. So you take note that the function is a polynomial, therefore it is continuous because a polynomial function is automatically continuous at every point. So if we visualize a problem in a Cartesian plane like this, we are interested with the interval -5 to 0. If we evaluate the value of the function at the endpoints, f of -5 is equal to 12, f of 0 is equal to -3, and try to plot these points. So you have here the points, and it is a quadratic equation, so you know that it should look like a parabola, right? We are concerned with f of c equal to 0. So basically, we're just looking for the value of x wherein the value of y is equal to 0. So we write the original equation here. And try to find the roots. Why the roots? Because we are concerned with f of x equal to 0. So based on the factored version of f of x, the values of x are 1 and -3. But because we are concerned with the interval -5 to 0, so the value of x is equal to 3 only. Next question, find the equation of the tangent line to the curve x squared plus y squared equal to 25 at point -3, 4. So because we're looking for the equation of a tangent line, which is a straight line, we will use the equation, the general equation for the line, which is y equals mx plus b. So first, we find the slope of this line, denoted by symbol m. We take note that this is the derivative of y with respect to x evaluated at negative 3, 4. So let us differentiate the equation with respect to x. The original equation is x squared plus y squared equal to 25. Differentiate that with respect to x. So we use implicit differentiation. This is the result. Dx over dx is equal to 1. So you are left and substitute the values negative 3 and 4. You will find the value of dy over dx. So dy over dx is equal to 6 over 8 or 3 over 4. This is the slope of the line, or m. Next, we find the y-intercept denoted by symbol b. We simply substitute the values for the slope of the line as well as the given point. So 4 is equal to negative 4 over 9 plus b. b is equal to 4 plus 9 over 4. Then we can solve this to find b equal to 25 over 4. So the equation of the tangent line is y equals mx plus b. Substitute the values for the slope m and the y-intercept. We will find this equation. We multiply both sides of the equation by 4. It becomes 4y equal to 3x plus 25. Or we can write this as 3x minus 4y plus 25 equal to 0. That's the final answer. Next question, number 15. Given f of x equal to 2x plus 1 divided by 2x squared plus 3x plus 1. Find the first derivative of f of x. So our approach is to first factor out the denominator so that we can write this in a simplified version, 1 over x plus 1. Then we simply differentiate it. So the answer, take note that okay, so the answer is negative 1 over x plus 1 squared. Next number 16. Given y equal to ln squared times cosine x, find the derivative of y. So first we take note that y equal to ln squared cosine x can be written as ln of cosine x squared. So in this form of the equation, it would be easy to use the chain rule. So chain rule is equal to the derivative of the whole function times the derivative of the inside times the derivative of the inside, and so on. So we get the derivative of the whole times the derivative of the inside times the derivative of the inside. Take note that I've just written this equation in a form that is easy to understand. But the idea of the chain rule is that you differentiate it like a chain, right? So you differentiate the whole thing, then the inside, and so on. So the answer, if you evaluate this, simplify, use what you have learned in algebra and trigonometry, the answer would be this. Next, number 17. Given the following function, g of x equal to 3 times ln of 4 minus x squared. Find the derivative of g of x. So again, we will use the chain rule. We differentiate the whole, then we differentiate the inside, and so on. Because 3 is a constant, we can just take that out of the chain rule. So the derivative of the whole times the derivative of the inside. The inside here is 4 minus 3x. The derivative of an ln function is 1 over the inside, right? Okay. So if you simplify this equation, you have g prime of x equal to negative 6x divided by 4 minus x squared. That is the final answer. Next, number 19. Given the following equation, y equal to 3x plus 2 raised to the third power, find the triple derivative of y. So we simply have to differentiate this 3 times. The first derivative is equal to 3 times 3x plus 2 raised to 3 minus 1, which is 2, times the derivative of the inside, which is the derivative of 3x, which is 3. So you evaluate that equation, you have this value. For the second derivative, we just differentiate the first derivative. The answer is 54 times 3x plus 2. And finally, for the third derivative, we just differentiate the second derivative. So y triple prime is equal to 54 times 3x plus 1. This should be plus 2. All right, but it wouldn't change the value of the final answer, which is 162. The next problem is a word problem. You want to enclose a rectangular garden with 12 meters of fencing. One side of the garden is already along a wall. So only 3 sides need fencing. What is the maximum area that can be enclosed by the fencing? So let us visualize this. You have a wall, so the length of the wall is fixed. We let the length of the wall be equal to L, so the opposite side would also be equal to L, and the width would be X. So we take note that the length, that the sum of X plus L and another X would be 12 based on the problem. So we can simplify this as 2x plus L equal to 12 meters, or L is equal to 12 meters minus 2x. So to find the area is simply length times width, or L times X. So we substitute the equation for L. You have 12 meters minus 2x times X. That is the equation for the area. So we can write this further as 12 meters times x minus 2x squared by distributing x. Now I would like to write this in the form negative 2x squared plus 12 meters times x, in order to emphasize that the equation is actually a quadratic equation. The coefficient is negative, so it is a parabola that opens downward. So the maximum area that we are concerned with is at the tip or the vertex of this parabola. So to find that, we take note that if we construct a tangent line that intersects the maximum area, the slope of that tangent line is equal to 0. So if we differentiate the equation for the area with respect to x, we will find the equation for the slope. We equate that to 0 so that we will have a horizontal tangent. So this becomes 0 equal to negative 4x plus 12. Simplify this further, it becomes x equal to 3. So that is the value of x when the area is maximum. We substitute this to our equation for the area. So you have negative 2 times 3 meters squared and so on. So you take note that the unit for the area becomes meters squared. The final answer is 18 meters squared. So this is the maximum area. So we can denote that by symbol A sub max. The final answer is 18 meters squared. This is number 20. The last one was 19 and 17. So we actually miss item number 18. So before we proceed to item number 21, let us solve item number 18. Problem is as follows. Given the following equation, y equal to negative 4 times e raised to 1 over x, find the derivative of y with respect to x. So we will use the chain rule here. Again, derivative of the whole times the derivative of the inside. Negative 4 is a constant. We can take that out. So derivative of the whole thing, derivative of e raised to 1 over x times the derivative of the inside, which is the derivative of the exponent, right? Now in this equation, the problem is actually e raised to negative 1 over x. Please take note of that. So I change the exponent. Okay, I have written the equation by taking note that 1 over x is equal to x to the negative 1. The derivative of e raised to 1 over x is also e raised to 1 over negative 1 over x. Then the derivative of negative 1 over x is equal to 1 over x squared. So this is the final answer. So let us now go to item number 21. So for this item, we will have another word problem. And the topic for this word problem is rate. This is related rates actually. So the radius of a circle increases at the rate of 0.01 centimeter per second. Find the rate of change of its area. So when we're talking of the rate, we take note that we are concerned with the derivative of a variable with respect to time. So find the rate of change of its area when its radius is equal to 6 centimeters. So the equation for the area of a circle is A equal to pi times r squared. So again, for For the rate of change, we are concerned with the derivative of the variable with respect to time. So we differentiate the equation with respect to time. Derivative of the area with respect to time, that's dA over dt, equal to pi, which is a constant, and times the derivative of r squared. So you will find that it is equal to 2 pi times r, derivative of r, with respect to time. Now we substitute the given values in the problem. R is equal to 6 centimeters, and the rate of R with respect to time is 0.01 centimeter per second. So here, we can solve this and find that the derivative of the area with respect to time is equal to 0.12 pi centimeter squared over second. Next problem, number 22. Evaluate the following. Integral of x squared minus 3x raised to negative 4 minus 3 dx. So we take note that this is simply getting the antiderivative of a polynomial. So we take note of this equation. So this is simply equal to the derivative of x to the fifth dx minus 3 times the derivative, the integral of x raised to negative 4 dx minus 3 integral of dx. So using the theorem that I have written here, this is equal to the following equation. So you take note that we have here a plus c term because this is an indefinite integral. So the final answer is written here, and we enclose that in the parentheses. Next problem, number 23. Evaluate the following. 3x plus 1 squared dx. You get the integral of that. You cannot integrate this straightforwardly, right? So you let u be equal to 3x plus 1. So dx is equal to du over 3. And you simply substitute the values of u and dx. So the first part is u squared. The next part, dx, is du over 3. So the equation is 1/3 times the integral of u squared du. So it is equal to the following equation. Then you put the value of u in the equation. The final answer is 1/9 times 3x plus 1 raised to the third power plus a constant. Next problem, number 24. Evaluate the integral of cosine 3x dx. All right, this is easy. Oh, again, by substitution, you let u be equal to 3x. So dx is equal to du over 3. We substitute u and du in the equation. So you can write this as integral of cosine u, and dx is equal to du over 3. So that is equal to 1/3 integral of cosine u du. You take note that the integral of a cosine function is the sine function. So the final answer is 1/3 sine 3x plus c. Next, problem 25. Evaluate the following. Integral of e to the x times 1 plus 4 e to the x raised to the third power dx. Again, we can solve this by substitution. We let u be equal to 1 plus 4 times e to the x. We get du. Derivative of 1 is, of course, equal to 0. So du is equal to 4 times e to the x dx. Now we can write e to the x dx as du over 4. We substitute this in the original equation. So we take note that we can write this equation as the integral of the quantity 1 plus 4 e to the x raised to the third power times e to the x dx. So the last part, which is e to the x dx, is actually du over 4. So this is equal to the integral of u to the third power times du over 4. We take 1/4 out of the integral. So what you have is 1/4 times u to the 4 divided by 4 plus a constant. So the following. So the answer is 1 over 16 times u to the 4. U is equal to 1 plus 4 times e to the x. So this is the final answer. Next, number 26. Evaluate the following. Integral of 4 dx divided by x times the quantity -2 plus ln x. So here we let u be equal to -2 times ln x. Du is equal to 0 plus 1 over x dx. So dx over x is equal to du. Then we do substitution. So you take note that the original equation can be written as 4 times the integral of 1 over -2 plus ln x times dx over x. Now dx over x is equal to du. Take note that we have taken 4 out of the integral. So you can write the equation as 4 times the integral of 1 over u du. So take note that we cannot use the theorem for the integration of a polynomial because the exponent of u is equal to -1. Instead, we take note that the integral of d over u is equal to ln u plus c. So the final answer is 4 times ln of u, which is -2 plus ln x plus a constant. Next, number 27. We have just 4 items left. Evaluate the integral of 6x plus 2x squared plus 1 squared dx. This time, this is a definite integral evaluated from 0 to 1. So we let u be equal to 2x squared plus 1. Du is equal to 4x dx. Du is equal to 4 times x dx. So we do substitution. Six can be taken out of the integral. So we can write the original equation this way. So you have a term inside the parentheses times x dx. Now x dx is equal to du over 4. All right. So we can write this as integral of u raised to the second power times du over 4. So that's 6 over 4 integral of u squared du. We change the variable of integration, so from 0 to u. Now, if we integrate this, there's no c anymore because this is a definite integral. the value of c will just be cancelled. So we have 1/2 u to the third power. Substitute the value of u, and according to the problem, the integral should be evaluated from 0 to 1. So we do it here. We substitute the value of the upper limit, which is 1, minus the value of the lower limit, which is 0. So we have 1/2 times 2 plus 1 raised to the third power minus 1 raised to the third power. So we have 1/2 times 27 minus 1, or 26 over 2. That's the answer. So the final answer is 13. Next number, 28. Evaluate the following integral. Integral of sine x cosine x dx evaluated from pi over 6 to pi over 3. So there are two ways of solving this. We can let u be equal to sine x, or we can also let u be equal to cosine x. It's your choice. So if we let u be equal to sine x, the value of du is equal to cosine x dx. So by substitution, cosine x dx is du, sine x is equal to u. So this is equal to the integral of u du from 0 to u. So the answer is u squared over 2 evaluated from 0 to u. So what you have is u squared over 2. Then substitute the value of u. So you have sine x raised to the second power divided by 2. Or you can write this as 1/2 sine squared x evaluated from pi over 6 to pi over 3. Take note that pi over 6 is actually 30 degrees. Pi over 3 is 60 degrees. So recall the values of the sine function in a unit circle. The sine of the angle is actually the length of the opposite side. For pi over 3, that is square root of 3 over 2. For pi over 6, or 30 degrees, that is equal to 1/2. So we just substitute these values in our equation. So we have 1/2 times 2 over 4, or 1/2, right? So that is 1/2 times 1/2. The final answer is equal to 1/4. As I've mentioned at the beginning of the problem, there are two ways of solving this. What we have used for u in this solution is sine x. However, you can also let u be equal to cosine x, and you should be able to get the final answer. Okay, so the word instead here should have an A. Next, number 29. Evaluate the integral of e raised to cosine x times sine x dx evaluated from negative pi to 0. So we let u be equal to cosine x. Du is equal to negative sine x dx, or sine x dx is equal to negative u. So we're just trying to express the original equation in terms of u. So sine x dx is equal to negative du, and of course cosine x is u. So we can write the equation as the integral of e raised to u times negative du evaluated from 0 to u. So take note that the integral of e to the u du is equal to eu plus c. So if you evaluate this using the upper and lower limits, u and 0, you have negative e to the u plus 1. Then you substitute uh, the value of u, which is cosine x. Now you evaluate the equation from negative pi to 0. So 1 will be cancelled because you're left with 1 minus 1. So a simplified form of the equation is negative e raised to cosine x plus e raised to cosine negative pi. Take note that cosine of 0 is equal to 1 and cosine of negative pi is equal to negative 1. So we just substitute that. So you have negative e raised to 1 plus e raised to negative 1. So you can write this further as negative e plus 1 over e. Then the final answer is 1 plus e squared minus over e. There's a correction here. It must be negative minus e, not plus e. And finally, for the last item, evaluate the integral of dx over x times ln x squared evaluated from e to to the third power. So first you take note that the ln of a raised to b is the same as b times ln a. So you can write the original equation as follows: dx over x times 2 raised times ln x. 2 can be taken out of the integral, so you have 1/2 before the integral. Now if you let u be equal to ln x, du is equal to 1 over x dx. Now 1 over x dx can be found in the equation, right? So you can write the equation as 1/2 integral of 1 over ln x times dx over x evaluated from e to the third power. And again, the integral of du over u is equal to ln u. So you evaluate this from 0 to u. ln of 0 is undefined, so you're just left with ln u. Then you substitute the value of u, which is ln x. So this is the equation. Next is you substitute the upper and lower limits of the integral. So you have this equation. So take note that ln e is equal to 1. So some terms here will be reduced to 1. Okay. Also, take note that ln 1 is equal to 0. So the second term will be cancelled. So you're left with 1/2 ln 3. So 1 of ln 3 can be written as ln 3 raised to 1 half. And of course, this is the same as ln square root of 3. That is the final answer. So that is the end of our video tutorial. I hope you enjoyed it.